In this lesson, we're going to talk about Objective 5.5, the collision model. So the learning objective states that we should be able to explain the relationship between the rate of an elementary reaction and the frequency, energy, and orientation of the molecular collisions. So we had talked at the beginning of this unit that the foundation of the entire Unit 5 kinetics is about particles colliding in order for a reaction to occur. So for successful transitions, reactants must collide in correct orientation to initiate bond breaking and bond forming events. Now, obviously, this still correlates with all the particles involved in the rate to be colliding in that correct orientation at that specific time. So it's really honestly hard for us to understand. In most of reactions, only a small fraction of collisions actually lead to a reaction, because the successful collisions need to have both sufficient energies to overcome energy barriers and orientations that allow the bonds to rearrange in the required manner. So we had talked about activation energy last unit, and we're bringing it back this unit, talk more about it, that EA. So honestly, a small fraction of molecules have enough E energy that's greater than the activation energy. So based off the graph, the minimum energy needed for a reaction to occur at EA, and you can see this is based off temperature. The dotted line is low temperature. The solid line is high temperature. And you can see where the activation energy, because kinetic energy, and you can see based off where these two lines hit that EA, based off the y-axis, a number of molecules, okay? So based off Maxwell-Boltzmann, based off the curve, knowing that these distribution of particle energies can be used to gain a qualitative estimate of the fraction of collisions that have sufficient energy to lead to the reaction. So it really shows us that the reaction rate is dependent on temperature. And we talked about that in the first part of this objective. So when we heat a sample, what kind of changes occur? Well, the amount of particles that meet the minimum activation energy does not change amount of activation energy needed. This is very, very, very important. So looking back at that graph, what that means here, if your activation energy, let's say, costs 1,000 joules. So if you want this reaction to occur, you need to have 1,000 joules to make that reaction occur. Here, increasing the temp did not change the amount needed. You just now have more particles at the higher temp that are going to actually collide. So here, you have a higher chance of particles colliding compared to the lower temp. So please note that correlation, because we are not affecting activation energy. We are just getting more molecules that could collide with enough energy to meet that minimum EA. If you were like, man, I thought Maxwell-Boltzmann wasn't coming back, it definitely will be back. Just this will probably be the last unit you will see it. All right, so let's look at this part right here. So orientation. So one thing to know about orientation is that specific parts of one particle must collide with a specific part of another particle in order for a successful collision. So when we mean by orientations, yes, it means that it needs to be colliding. In some cases, it could be head-on. But also if it's head on, it has to be hitting the correct part of that molecule. Okay, because if you can see in that diagram to the right, here only one orientation allows for a reaction to occur. You can see the same, if you look at that unshaded circle, so I'm talking about this shaded circle in all, the one that's attached to the green shade. So the same unshaded circle needed to collide with the double bond in the other molecule. So you can see in that other molecule that's, it shows a double bond. So this part right here, double bond. Only collision 1 shows the correct orientation. You need to have this little unshaded circle perfectly collide with that double bond. It didn't work in collision 2 because here you have the green larger circle hitting the double bond. That doesn't work. Collision 3, this is hitting this molecule, this part of the molecule right here, which is not the double bond. And here, this is colliding with one of the surrounding atoms. That is not the double bond. So here, not a successful collision. So it honestly, truly matters on talking about that particle scale, how those particles need to be reacting or in the correct orientation. So the overall message of collision theory, particles must collide. Sweet and to the point, right? Here, the rate of the reaction is dependent on the frequency of those collisions. Then they must have sufficient energy. Here, it is that energy, let me spell that a little bit better. That is the energy that will be greater than the activation energy. Again, if your activation is 1,000 joules and you only have 999, that doesn't cut it. We need to have energy that's greater than the activation energy, okay? Because that is the energy needed to break those bonds to help us form new ones. And lastly, the particles must be in the correct orientation. Here, certain parts of molecules must meet for reaction to occur. So different parts of that molecule compared to the other one have to collide as well.